Hello everyone. Today we solve a very interesting question. This question is asked in IIT JAM Mathematics 2024 and this question is from the real answers part. Okay. In the given question, AN, BN and CN are three sequences, three convergent sequences, and A1 is equal to 1, B1 is equal to 2 and C1 is equal to 3, and there is a recurrence relation between these three sequences. This is the recurrence relation. Okay, and from this recurrence relation we will conclude the limit of the sequence, because this sequence is a because the sequences are convergent sequence. First of all, we have to find the limit of these sequences, and these limits will be used to calculate the sum of this series. Our final aim is to calculate the sum of this given series. Okay, so before going to calculate the sum of the series, first of all we have to calculate the limit of the sequences. Okay, what is given? The information is A1 equal to 1, B1 equal to 2 and C1 equal to 3, and the recurrence relation AN plus 1 is equal to this one, and BN plus 1 equal to this, and CN plus 1 equal to this one. Okay, but we know that limit of AN plus 1 is always equal to limit of AN. These things will be used. If we will apply the limit on equation 1 on both sides, then what we will get? Here in the left hand side it is denoted as A. Limit of AN plus 1 equal to limit of AN, which is equal to A. This limit is A and this limit is A. Similarly, limit of BN plus 1 and limit of BN are same. If we will apply limit on equation 1 on both sides, BN will be B. Okay, so from equation 1 what we will get? In the left hand side it will be A, and limit of AN is A and limit of BN is B. So we will get this expression. Okay, from this we conclude that A equal to B. Similarly, if we will apply limit on both sides on equation 2, what we will get? We will get B equal to B plus C by 2, which gives B equal to C. Okay, so from equation 3 and 4 we will conclude that A equal to B equal to C, means the limit of the sequences are same. Okay, and if we will add these three equation 1, 2 and 3, in the left hand side what we will get? AN plus 1 plus BN plus 1 equal BN plus 1 plus CN plus 1. In the left hand side we will get this term. Okay, and in the right hand side if we will add these three things, we will get twice of AN, twice of BN plus twice of CN, but here half is also there, so it will cancel. So finally we will give, in the right hand side it gives AN plus 1, BN plus 1 plus CN plus 1. We will get this equation, and this is a nice equation because this sum is not changing. This, if we denote this sum in the left hand sum is expression sum Cn and Cn plus 1, and this not Cn plus 1, let me give a different name, Dn plus 1, and if we will denote this will be Dn, means Dn plus 1 is equal to Dn, and if we will keep going decreasing in the recurrence relation, so it gives equal to D1. What is D1? D1 is A1 plus B1 plus C1. If it also, one can also take example. For the particular case, if we take n equal to 1, it gives what? In the left hand side A2 plus B2 plus C2, A2 plus B2 plus C2, which is equal to A1 plus B1 plus C1. If we take n equal to 3, what it gives? It gives A2 plus B2 plus C3 in the left hand side, and in the right hand side A2 plus B2 plus C2, but A2 plus B2 is C2, A2 plus B2 plus C2 is equal to A1 plus B1 plus C1. So finally we will get always the constant, always this AN plus BN plus Cn is always a constant sum, which gives always A1 plus B1 plus C1. Okay, so this sum is a constant sum which always gives A1 plus B1 plus C1. Instead of n plus 1 we simply write AN plus BN plus Cn, which gives always A1 plus B1 plus C1. So if we will apply limit on this both sides, what we will get? It gives limit n tends to infinity AN, limit n tends to infinity BN plus limit n tends to infinity Cn, and in the right hand side A1 plus B1 plus 1, what is the value of A1 is 1 and A2 is 2 and A3 is and C1 is 3, so it gives the sum 6. Okay, and in the left hand side these three limits are same, so it gives 3a equal to 6, a equal to 2, but we know that these limits are same, so we will get a equal to b equal to c, which is equal to 2. Okay. Now let us find the sum of the series, that this series. Our ultimate aim is to calculate the sum of this series. Okay. So let me write the series. Here we have to take care of the infinite series. It is not, and we do not know the convergence of the series, whether this series is convergent or not. So we have to deal with carefully. So first of all, we have to convert this infinite series to a finite partial sum, limit of the finite partial sum. Okay. If we, and it is converted to a limit of the finite partial sum, then we can proceed. As usual. But we cannot proceed directly by expanding it by and dealing with the infinite series, because infinite to handle with the infinite series, first of all we should know that the sum of the series is finite, but in our case it is not given, so we have to convert it in the partial sum. After that we can proceed as usual. Okay. So first we converted to into a partial limit sum, and then we proceed. After the expansion, the first term and the last term got cancelled, and if we arrange these two terms, the second terms and the third terms, then it gives what? Then it gives a telescopic series, this one. Okay. It gives the telescopic series, this. Okay. And we know that telescopic sum always gives the last term and the first term, so it gives this and this. Okay. And if we will apply the limits, so okay, here the last term is not n plus 1, it is k plus 1, because the n term will be k plus 1, b k plus 1, and c k plus 1. Okay. And if we take the limit on the both side, k tends to infinity, so it gives k plus 1. Okay. It gives we have already calculated the limit. These limits are same, and it gives these limits are same, which is equal to 2. It gives 2. So 2, 2, 2, and a value of the a1, b1, c1 and are given. A1 is equal to 1, and b1 is equal to 2, and c1 is equal to 3. So it gives the 8 minus 6, so which is equal to t, which is equal to 2. So 2 is our correct answer. Okay. I hope you all understood it very well. Thank you all.